Hi everyone, welcome to this session. Today we will be solving problem of the day, that is count square submatrices with all ones. So let's start. So this problem states given a m cross n matrix of ones and zeros. So in the given matrix only 1 and 0 is allowed. Okay. So our range of element is from 0 to 1. Return how many square submatrices have all ones. So we have to return count of how many square submatrices are present which consist only ones. Now question arises, what is square submatrix? So this is the definition. A matrix which has same number of rows and columns, that is called square submatrix. Let's see the example to understand it more better. You can see here number of rows are 3, 0, 1, 2, and number of columns, and there are 4 columns. So there are 10 squares of side 1. That means you can assume it size 1. So there are 10 square matrix which has size 1. Size 1 means row is 1 and column is also 1. So let's see. So we know square sub matrix consists the same number of row and column. So this can be our submatrix. This number of row is 1 and number of column is also 1. But this submatrix consists 0. So we can't include it. Let's see another one. This one. Yes, we can include 1. This one also 3, 4, 5, 6, 7, 8, 9, and 10. So you can see for size 1 we have 10 submatrix. Next is there are 4 square submatrix of size 2. How? You can see if we are at here and we will take size 2, that means row 2 and column 2. So this is the submatrix. But you can see there is 1 0 which is not allowed, so we can't pick it. Let's see, we are at here. Now assume we are at here. So we can pick 2 row, 2 columns. So this is our one sum matrix. If we are at here, we can pick this one. Similarly, if we are here and we pick this is not allowed. So if we go here, we can pick this sub matrix of size 2. Then we are here, we can pick this sub matrix. Similarly, we have to go at each element. If we are at here, if we go for size 2 submatrix, so this is not allowed. We can't pick this submatrix. Let's see one more example. Okay. There are 4 rows and 3 columns. So suppose we are at here and we are picking size 1, we are picking size 2, then we are picking size 3. So you can see till now size is allowed. If we pick size 4, means 4 rows and 4 columns, but you can see there are only 3 columns. So size 4 is not allowed at any point. That means our size is depend on number of rows or number of columns. So our size should be from 1 to minimum of m comma n. You can see here m is 4 and number of columns are 3. So minimum is 3. So we can only pick some matrix of size 3. So in this example also, then there is one square of size 3. How? You can see this one. If we are at this point, we have 3 rows and 3 columns. But if we go any other point like this here, we can't pick, we can pick 3 rows, but we have no 3 columns. We are unable to pick 3 columns. So now, so what are the steps to solve this problem? So we are discussing the brute force approach. So first step is we have to use two loops to traverse the given matrix. We know if we have to traverse each and every element in the 2D array, then we need two loops, one for row, one for column. After this, then we know for each element we have to expand it from size 1 to minimum of m comma n, because we know we are going at each and every element. If we are at here, we are expanding this element. Firstly, size 1, then size 2, then size 3. But you can see if we have pick size 3, still at this point, size is not valid. Okay. So again, after calculating the range, we have to check our row end, our column end. Okay, this is column end and this is row end. So after calculating this range with the help of size, we have to check is it valid or not. Okay. Then we have to calculate the range. In fourth point, the next step is we have to traverse the square submatrix. Now with the help of range, we know in this large matrix, now we have to find this. We have to check this submatrix whether it contains all ones or not. So then again we need two loops. Okay. Again we need two loops to traverse the square submatrix within the range. So let's see in the code that how I solved that question. So you can see, firstly, we have to take an answer variable which we will return at last because we have to return int, that is number of count. Then I already told you that we have to pick minimum of m cross n. So m is matrix length, that is number of rows, and n is number of columns. And to find number of columns, we have to find the length of 0th array. Okay, and this is to find the number of columns. Then we are using two loops to find the to traverse each and every element in the given matrix. Then second step we have to calculate size from 1 to minimum. Okay, this is the minimum of m cross n, and we are calculating row end and column end. Then here we are checking if our row end or column end is out of bound, then we are breaking this loop. Because if at any point our row end or column end is out of bound, that means further we do not need to calculate size. Then we are taking a Boolean flag. Why? Because now we are checking. Now we are traversing this submatrix whether it contains all ones or not. So normally we traverse the 2D matrix. Similarly, we have to traverse this square submatrix. So you can see for each and every element I am checking if my value is not equal to 1. I am setting this flag true and breaking this loop because now I do not need to check. And why flag true? Because after breaking this loop, there is another for loop or rows. So I am checking if my flag is true, then we need to set count equal to 0 and again break this loop. If all square sum matrix elements are 1, then it will add count as 1 because we have to return number of square sum matrix consist all ones. Okay. So after this sum matrix traversal, we need to add this count. It can be 1 or it can be 0. We need to add this count to our answer. Simply then we have to return our answer. So let's discuss the time complexity and space complexity. Time complexity for this solution is m into n into minimum of m comma n cube. This is our time complexity. This is for traversing the given matrix. Then again one loop for size and two loop for traversing the square submatrix, which can be minimum of m comma n. So this is our time complexity because total we have 5 loops. And space complexity is big of 1. We are not taking any extra space. So I hope you understood this problem and solution very well. Thanks for watching. We will meet in the next video.